Chapter 9, Differentiation. At the end of this video, students should be able to find the derivative of a function using the first principle. Firstly, you need to know that dy dx, the differentiation dy dx can be written as f prime of x and equals to d dx of f of x. And given here, the formula for first principle is dy dx equals to f prime x equals to f of x plus h minus fx over h as h approaches 0, where f prime x is the gradient of the tangent to the curve. Okay, so you need to remember this formula. Okay, now we go to example 1 on page 2. Find the derivative using the first principle. Okay, we know that the formula for first principle is f prime x equals to limit f x plus h minus fx divided by h as h approaches 0. Okay, what is the meaning of f x plus h? Meaning that we need to plug in x plus h into f. We replace x with x plus h. Okay, so for this case, we will get f prime x equals to, limit h approaches 0, fx plus h is x plus h square minus 4 x plus h plus 2 minus fx. So we write fx minus, fx is x square minus 4x plus 2, and now all divided by h. Okay, next we need to expand the quadratic term here. Okay, so we will get limit as h approaches 0. Okay, the function becomes x square plus 2xh plus h square minus 4x minus 4h plus 2 minus x square plus 4x minus 2 all divided by h. And if you notice here, we can simplify a few terms. X square with negative x square, negative 4x plus 4x, 2 minus 2. So now we have 2xh plus h square minus 4h only. So equals limit as h approaches 0, 2xh plus h square minus 4h divided by h. And if you try to substitute h equals to 0 inside, h equals to 0 here. If we substitute inside, we will get 0 over 0, which is undetermined. And for this case, we need to factorize the numerator. So we have limit h approaches 0. We take out h, so we have 2x plus h minus 4 divided by h. H divided by h can be simplified. So now we just need to substitute h equals to 0 into the function here. So we have 2x plus 0 minus 4. So the answer will be 2x minus 4. Okay, now we go to the next one. Okay, the derivative at a point x equals to a. So the formula for derivative at a point is f prime a equals to limit fx minus fa divided by x minus a as x approaches a. Okay, example 2 on page 3. By using first principle, find the derivative of fx at x equals 1. Okay. So for this case, we have f prime, the number is 1, equals to limit x approaches a. For this case, x approaches 1. Okay, we substitute fx, x squared plus 3 minus fa. So what is fa? fa is f1. So we substitute 1 into the function. So will be 1 square plus 3 and divide by x minus 1. Okay, we simplify the numerator. So we will get limit as x approaches 1. Now numerator becomes x squared minus 1 and divide by x minus 1. If you try to substitute x equals 1 into the function, we will get 0 over 0, which is undetermined. Meaning that we need to factorize first. So limit x approaches 1, x squared minus 1 can be factorized as x plus 1 times x minus 1 and divide by x minus 1. And the function becomes x plus 1 only. Okay, as the final step, we substitute 1 inside, so we will get 1 plus 1 equals 2.